Hi guys, if you are joining me, sorry, I'm just setting up for the YouTube side of things. So if you want to join me in the session, please do click on the link that I've just shared. If you are joining me on TikTok, then please do jump over to my YouTube channel and you will see the session that's there. Okay. Hi, welcome. So I promised Chidima, I'm not sure if you are here. Chidima, I said it wrong again. Chidima, I'm not sure if you're here yet, but I promised her that I would do AS stuff tonight. So for those of you who are in year 13, this is really good for you as well to cover the year 12 content. And the reason I say that is because a lot of your content that you need to know for year 13 is built on the foundation of year 12 content. Hi, Andreas, lovely to see you. So if you are just joining me, we're going to go through some of Chidima, I just actually mentioned you, I'm on YouTube. Jump over. I am going to look at year 12 content and I'll actually build in, for those of you who are just joining me for the first time and don't know how I work, I will be building in the year 13 content as well, because that's how I do it. And I will do it in a way that ensures that I'm taking you down that path of where they could go. Because these past papers, just to be aware, they're never going to be used again. But what they might do is they might reword a question, or what they might do is they might actually just adapt the question. So it's important that when you are doing this, that you note what is actually being asked and what's expected. So let's start with the first question and go through what it is that you need to know. So if you are joining me on the Zoom Live, then I'm trialing a new thing because obviously last time any noise anyone made, it did actually switch away from me. So because this is being live streamed on my YouTube channel, I'm trialing new things. So if you are wanting to ask any questions, if you've got anything that you want to discuss, then please do put it in the chat and let's get going. So this question, I'm going to start, and this is paper 2, AS 2021. So what we'll do is we'll go through with some highlighting. And this one is interesting because they've told you that glucose is the monomer of the polysaccharides, such as glycogen and starch. So the first thing I would do is I would start by ensuring that I have a way to explain what is going on in my own head. I'm not jumping to the question. So, Chidima, I see that you've already jumped to that question. And that's the thing that I would say, don't do that in one of these papers. When you're revising, take your time to go through and to help yourself to pull that information forward. So if we look at this first one, we know glycogen. So I would straight away be adding little notes myself that glycogen, I know, is branched. I know that starch is made up of 2 different molecules, amylose. I don't believe you don't do that in the questions. Amylose and amylopectin. I'm actually surprised as well for how many students who I say this every single time I do a session. I say you should be using highlighters and you should be highlighting all over your paper, but not your answer. So do not highlight in the position of where you answer it, but also make sure that you are highlighting so it sticks out and you're actually able to pull that information. So when you have a second look at the question, you've already gone through and taken the time. Now, the other thing I have, if I the other thing I would say that you do actually have is that some people highlight everything. That's not going to work for you either. So what you need to do is you need to make sure that you are highlighting the key words that are going to help you. So let's just carry on with some highlighting. That is true. To be fair, if you weren't reading it, you wouldn't be hitting those A stars. So we're told that the glucose is an important source of energy. We're told that it's transported in our circulatory system. So again, I would straight away tell myself, well, what is it meaning by the circulatory system? So it's talking about my blood plasma. Because we're talking about glucose, and we know that glucose is a molecule which can dissolve, which is obviously what the question is going to be focusing on, that first one. Then we're given some more information in that we're told that glycogen is an energy storage molecule found in many animals, and starch is found in many plants. So again, I'm going to annotate some notes for myself. So energy storage, which means if it's a storage, it can be built up and broken down quite quickly. So the hydrolysis and condensation reactions that can occur mean that it can be built up and broken down for when it is required. And then the last bit of information they've told us is amylopectin is one of, oh look, two polysaccharides, which we already named, amylose and amylopectin, and it constitutes the molecular structure of the starch. So let's actually see what the question is asking us then. So state one property of glucose that allows it to be transported in the animals. Well, we know it's going into the blood plasma. We know that that is made up of water. Water has got a solvent property. Therefore, we know that it should be able to form hydrogen bonds. If we have a molecule which is soluble, or the fact that it is polar. So that's one of the ways in which it's asking you to identify what you know about the structure of glucose, and also checking if you understand water, which is part of your biological molecules topic area. So then it's asking about the structure of glycogen and how that is different. Let me bring you guys up here. So how is the structure of glycogen different from the amylopectin? Because we just said branch for glycogen, and we did amylopectin and amylose. Now, I would have added in some extra notes here. Amylopectin is branch because it has 1 to 4 and 1 to 6 glycosidic bonds. Whereas amylose only has 1 to 4 glycosidic bonds. Now, it's not asking me about them right now, but it is important that I am able to add that in. So how's the structure of glycogen different to that of amylose? Well, glycogen is branched, amylopectin is branched. So how is it different? Well, for every 10 subunits, that is where you get a branch in the glycogen, whereas in amylopectin, it's every 20 subunits. So therefore, one of the ways that we can talk about it being a better energy store in animals is because there is more branches in the molecule. Not only does it have more branches within the molecule, it's actually got more of a coiled structure. So it can compact up more than the starch molecule can. So it's more coiled. And then we can say, right, well, if it is, as I said, more coiled, you've got it being more compact. I'm therefore giving them 3 marks worth of an answer just by describing what I already know. So I want to give a bit more than that because, as I said before, It is a storage molecule. And because it's a storage molecule, what it means is it can be built up, as I said before, and broken down. Now, in the exam, don't ever use that generic term. Try to use more scientific or key vocabulary. So things like, so Paul, to answer your question, they do need to know that it's a 1-to-4 alpha link, but it's one of those things, excuse me, that it's assumed that they will just know that. So they only call it a 1-to-4 linkage or a 1-to-6 linkage, but they should know that because it's an alpha, then that's like an assumed part of it. But when it comes to the exam, they tend to be looking more at the beta glucose. And if they can identify that with a beta chain, it is a beta glycosidic bond. There's more branch, so glucose can be removed. Yes, perfect, Andrea. So you can add or remove the glucose more rapidly. Perfect. And they love you to actually give more information about that. What do you mean by that? Well, what we're talking about, how do we remove it? Let's give them some key definition here. It means hydrolysis can happen faster. So that's just another way. Enzymes can act simultaneously on ends of glycogen. Is that you asking the question, or are you actually stating that that is one of the answers? So Amna, is it right? Okay. So yeah, so because there's so many free ends, that means that hydrolysis can happen simultaneously at each of the ends. Absolutely. So you wouldn't get the marking point for talking about the enzymes can act simultaneously on those ends, but by saying there's more free ends is what it's wanting you to actually give them as an answer. So more free ends. Yes, Chidima, absolutely. Saying it's insoluble would be ignored because it's not looking for that. It's looking for you to say this one has this, whereas that one has that. So it's important to note the thing that it said was that differs. Okay, let's move on then to the next question. So the next question is looking at the structure, and you've been told in the question that you have a beta glucose. So straight away, they've given you a little hint. They are expecting you to be able to identify if that's carbon number 1, there's carbon number 2, there's carbon number 3, carbon number 4, carbon number 5, and carbon number 6. I know that that's my 6 carbon molecule because glucose, whether it's the alpha or whether it's the beta, is a 6 carbon molecule. Therefore, what would be differing? The differing part will be that hydroxyl group. Wow, my brain just stopped there for a second. The hydroxyl group and the hydrogen. Oh, it's been one of those days again. Yes, they do if you're asked to actually draw it. Yes, it does matter. So how I remember it is with regards to the glucose, you would always have the hydrogen below. So I always think it's a bit of a weird one, but glucose is HO, whereas the ribose is HO. I don't know why I remembered it that way, but it actually did help me. So this would be if I'm looking at ribose, and this would be if I'm looking at glucose. Now, Paul can probably jump in here and tell you that there's some reason for that, but I've never bothered to remember that. I don't care. I'm like, how do I actually Mother Christmas? So if you drew the alpha glucose for this question, would you get the mark, or do I have to say the difference using words? So in this case, because it's actually looking for you to shown on the diagram. So interesting, they have said, I'm just looking at what they'll allow in that mark scheme just to be on the safe side. So they have said allow C1 position to be shown on the diagram. So that therefore means that a lot of students have done like me. They have drawn on the diagram to show it, but ideally, if they're asking you to describe, what they really want you to do is describe it in words. So therefore, in the try this again. In the picture, what we have to understand is we have our hydroxyl group. So I have my OH group and I have my hydrogen, and they are going to be in the opposite position. So the hydroxyl group and the hydrogen are the opposite. Now, this is important on carbon number 1, and it's important that you state that it's only carbon number 1 so that you can actually see that if it was looking at the opposite with the alpha, I would draw a hydrogen above and the hydroxyl group below. So I would always, for me, because I'm a very visual person, I would make sure that I'm drawing it just to help make sure that I've seen what it is I want to say. And it also helps the examiner because it shows them, but obviously it's not expected. Oh, no, wait. It is when it comes to the ribose sugar. So it wants you to complete the diagram to show the position of the carbon atoms. So again, it's specifically only saying the carbon atoms. There is no need to include the hydrogens and hydroxyl groups on this one. So do make sure when you are reading the question that you don't do more than you need to in the question. So we know that we are looking at a ribose sugar that has 5 carbons. So if I know that there's my carbon 1, my carbon 2, my carbon 3, my carbon 4, I then have a 5th carbon that I need to add in because it is a pentose sugar. We know it's pentose. And if I were looking at this and I was trying to figure out what ways to determine the difference between a deoxyribose and a ribose sugar, what I would be doing is identifying the carbon number 2. So you should know if we are looking at a deoxyribose sugar, that means DE removal of an oxygen. So with regards to a ribose sugar, which is what it has stated in the question, if I were expected to draw this, I would have to draw my hydroxyl group down at the bottom. How would you not be able to memorize that? Chidima, what do you mean? What bit are you struggling with? Do DNA, you'll learn about deoxyribose and ribose, but I don't think you need to know it in much detail. No, you don't need to know it in much detail, but you do need to know what they mean when they give you a picture. So sometimes they will confuse you by actually showing you a picture of a structure. So for example, if I give you an example down here, if I were to draw a nucleotide, so here we go, we've got our ribose sugar, we've got our nitrogenous base, and we've got our pentose. Pentose, no, we don't. We have our phosphate. Let's try that. If I've got my phosphate with my pentose sugar with my nitrogenous base, what they will tend to do is they will draw it down here as an OH, or they may actually not draw it at all, and they will therefore leave it blank with the assumption of it being an OH. So if there is nothing there, nothing drawn, there is an assumption that there is a hydroxyl group present. So when you're looking to distinguish between, as they've done in the past, a RNA nucleotide and a DNA nucleotide, you therefore need to look at that carbon number 2 to see, did they draw it with only a hydrogen or did they draw it with a hydroxyl group? Because that is one of the ways in which you can determine whether you're looking at a DNA nucleotide or whether you're looking at an RNA nucleotide. So that is one of the ways in which you can do. How can you see what I'm doing, guys? Sorry if you're on my TikTok. I'm over on my YouTube channel, Biology with Christine, and showing it on the live screen there. There's also a link there that you can join the live Zoom if you want to. Yep, you're absolutely right. There is a live stream on my YouTube channel. Okay, let's keep going. So this next question then, what we're being asked to do is look at some information. So again, it's important that you take your time when going through this. So this one, you're being told about the immortal jellyfish and the sea bass. So again, I would be adding in a few things of notes to help me to prep myself. So I can see that I've got my genus and my species, my genus and my species. They're both found in the Mediterranean Sea. So I have two different organisms. I also have been told about their genus species. So in my head, I'm thinking they might ask me questions on this. They might not. They might just have thrown it in for a way in which to confuse you because there's a lot of information. This is a way in which they're checking your reading comprehension and they're checking your ability to see whether or not you actually can pull information out of the question. So many students think it's all about memorization. It's really not. I know, sneaky examiners. It's really not about memorization. It's about your ability to apply the science that you've learned, A-level biology, to the random concepts that they've given to you. So it is really important that you take the time because although they're sneaky, they're also being a bit helpful if you know where to look and what to look for. So sneaky if they just want to make it harder for you, and that's when you tend to get like a page worth of information to read. But on the other hand, sometimes there is actually information that you need in the starting point. Okay, so if we continue on and see what they have given us. So they're telling us about the surface area and they're telling us about the volume. So straight away in my head, I'm going to go, well, I already know I need to know about my surface area to volume ratio. So if I've got my surface area to volume ratio, if I understand that, I understand that whatever I divide my volume by, i.e. 1.5, because I always want to get my volume to 1. So with regards to OCR, they want you to always get your volume to 1. So if I'm dividing that by 1.5, I divide that by 1.5. If I'm dividing this by 810, I'm dividing this by 810. So I can therefore work out my surface area to volume ratio. Now, the next thing I'm going to highlight here, I'll use a different color, is I'm going to also highlight the fact that they have shown me in this table of results parts of the bit that they may assess me in when it comes to module 1. So look at the fact, oh, no, don't look at that. Let's remove that. Let's try that again. I'll do it with the color. Look at the fact that here they have given me a title with a unit, a title with a unit. They've also done it to 1 decimal point. Therefore, when you come down to the sea bass, they have to add in the 0.0. So when you are going through and doing your practice, you need to look for these little bits that they've done in previous questions. If they're not asking you to evaluate or improve any of the parts in a table, in a graph, that means that they have done them perfectly as how they expect you to do it in your exam. So use that as a guide when you're making your own revision notes. Use that to help you. Oh, look, I must put titles at the top. Anyway, let's keep going and look at what else they have told us. So a student made the following statement. The immortal jellyfish does not need a transport system. So I'm going to highlight does not need a transport system to transport oxygen as it has a very large surface area. The sea bass does not need a transport the sea bass does not need a transport system as it is a larger organism. So, sorry, does need even. Let's try reading that properly. See, this is where my reading, and again, if you're like me and you sometimes read something and you insert words or you read it and you flip it around the wrong way, that means you need to take the time when you're reading the information that's been given to you, because if you read it wrong the first time around, as I did, I said the sea bass does not need a transport system, when actually the question's saying the sea bass does need a transport system. Now, if you were actually in my class and we were doing this face to face, I would then be saying to you, I'd say it out wrong, not intentionally because I've made a mistake, I'm human, but I would hear it. I'd hear that I'd said it wrong, as I just did, and I would then identify that's wrong. And then I say to my students, is that right? And they're like, yeah, that's right. And that tells me straight away that they're not listening. So it's important that when you do this, whenever you are going through these practice questions, that you are actually really engaging in your learning. Also, when you're in your classes, and don't get me wrong, I know I'm droning on right now. If your teacher's trying to explain something and you've stopped listening, you may only be picking up the bits of the conversation. You then try and regurgitate that on paper, and you only have those snippet bits of the topic area. Yeah, I do. Do you know what? There are some times, to be honest, Paul, that I do say some things wrong on purpose to see if my students are listening and paying attention. And as well, there are times when I make mistakes, because we all do. We pretend sometimes we don't, but teachers are human after all. Okay, let's actually look at the question. So in this one, again, it's asking me to evaluate. So evaluate what they've said. So therefore, I need to do a bit of processing of the data that they've told me. So I've already said I'm going to divide each one by 1.5, and that should give me that my ratio is 7:1 for the jellyfish. And with the sea bass, my ratio is going to be, what's it going to be? In this case, if we're going to look at the sea bass, we're going to need a calculator, because that one was easier. Where are we going? A calculator. 1 to 3, Sarah, thank you. 1 to 3. That doesn't make sense, because you've divided it by 90. So it's important that when you're doing this, you need to think about how you are taking that surface area to volume ratio to which way around you're going to do it. So you did it by dividing it by 90, whereas I said before you want to do it to a one with regards to this one. So if I want to get this to 1, I would therefore have to divide my 270. So let me just do that one a second. 270 divided by my 810, which would give me a 0.3 to 1. So it's important that you note, majority of the time you want to get it down to 1 in the volume area. They will accept both ways. So just to be clear, they will accept both a 1 to 3 as well as a 0.3 to 1 ratio, as long as you've got it the right way. So just be aware on that one. Need to consider other factors such as, good, thank you, Chidima, you're absolutely right. So one of the things you should always consider with the transport system is thinking about the metabolic demand. So the metabolic demand is always one you want to be talking about, so you can be sure that you know, is this an organism that's going to need a large supply of oxygen, or is this an organism that's not going to need that much? So this is an interesting one. You're absolutely right. Be very careful that you do take the time. Chidam, I'm going to pick you up on this one because you identified it. they're both in the same place. They're both found in the Mediterranean Sea, and therefore they're being exposed to the same environment because they live in the same habitat. So what you then need to think about is about, which is the second part of your answer, your diffusion distance. So, sorry, I'm not trying to pick on you. You're just really quick at answer. It takes me a while to read the questions. What is that? Why are you flashing at me? Right. Okay, so using the data to evaluate, well, we can say we want to calculate, it's looking at our surface to area to volume ratio. Oh, see, this is, I always do that. Whenever I try to write ratio, I always write ration. I don't know why. Exactly, Paul. It is about pushing students to be the best that they can be, regardless of whether you are a U candidate or whether you are a A-star candidate. I will always push you because you want to get the best possible grade. And if you make a mistake somewhere, then that could be the vital one extra mark you needed for the next grade boundary. So it is always important to push yourself and to be okay with making mistakes. You learn by making the mistakes. So if we look at the surface area to volume ratio, we can quite clearly see that the jellyfish is a 7:1, as we said, and we've therefore got that it's 0.3 to 1 with regards to the sea bass. So the surface area to volume ratio is much larger in the jellyfish compared to the sea bass. The other thing to note is about that diffusion distance. So the larger the diffusion distance, the less likely that the oxygen is going to be able to get to the cells at a fast enough rate to meet the metabolic demand. Therefore, you're going to need for that distance for the oxygen to travel to not be too far. So that's why you need a transport system. So if you think about the fact that the sea bass has actually got more cells in it, the volume is much larger. So there's more cells in the sea bass. So therefore, the distance that oxygen has to travel is going to be too great for diffusion alone. So it is important that you note the diffusion distance, but then you link it back to the question. So with a large volume, let me just move this up a bit. Large volume in the sea bass means more cells. So the distance too great for diffusion alone. So it is important whenever you're doing evaluate that you do it so you are ensuring that you have given arguments for and against as well. Okay, so we're looking at the circulatory system of the sea bass. Now, the other thing I would say to you, for those of you who are year 13 at the moment, doing AS papers is actually really good because what they can do is they can take the AS papers and then change them slightly and put them into the year 13 A-level exam. So you didn't get any questions on fish exchange systems last year, and also there wasn't very much on insect exchange systems. And I heard actually when I saw a video on my page today, the AQA was very similar in that. So it's an interesting part of researching the papers where you start to see some themes being that they haven't covered them in a while. So therefore, this is year 12 content, does not mean it's not going to be assessed in the year 13 exams, because remember, it's 1, 2, 3, and 5. And this is the module 3 content. So that could be in paper 1 or it could be in paper 3. So there's 2 places where this content could come through, like a dissection, for example, of a fish. Now, just to be clear, for those of you who don't know, I am not employed by OCR, not employed by OCR at all. And I made my YouTube channel and I make these videos because I started teaching OCR a couple of years ago. Again, I hadn't taught it for a while and I started teaching it again. And I started looking at what resources were out there to help me, to make it easier for me to teach, because I was too lazy and couldn't be bothered to read the textbook. And also, I wanted my students to go somewhere outside of my lessons. And unfortunately, there was nowhere to direct them. So I made my channel and I made my resources to help my students. And a lot of you who are with me now have been with me because when I went live for the first time on their first ever exam last year, a few of the students were like, this would be so good. You should do a YouTube channel. You've helped me so much. And so therefore that kind of started this whole process. So I would say to you, just to be clear, I do not work for OCR. So anything that I say to you with regards to any thoughts that I have, any guidance that I give you is from my experience of my 20 years of teaching. Okay, 20 years of teaching and analyzing every single one of those papers. And I analyze them on such a regular basis because I tutor privately a number of students as well. So I'm constantly reviewing all these papers and I'm also wanting to make the resources better. I never teach in the same way. So I would definitely just say to you, if I say something in any of my sessions and you then think, oh, she knows because she's seen the papers, I haven't at all. I have no idea. But I feel, I'm going to be honest, I feel sometimes when I'm doing these things that this may be something, because I haven't seen very many questions on this, for example. So a dissection of a fish, I've seen 2 questions come up on this, and mainly they're in AS papers, but it doesn't mean it can't come through on an A level paper. I do feel like there's a dissection coming. I don't know why. There's something, but Chidima, you are next year. You have another year to go, so we'll know by that point if it came up this year. But okay, back to this then. So what we can see here then is they've told us we've got the heart, we've got the capillaries in the gills, and we've got capillaries in the rest of the body. Now we know the gills is where we're going to have the gas. Oh, try that again. Gas exchange. Oh, really? I never actually dissected a dogfish shark. I did dissect, I want to say it was a rainbow trout when I did it for university. But the worst one for me was actually the chick. I felt really bad dissecting when I did it at uni because we had to pluck it before we could actually get in to dissect it. So that stressed me out. And when I did the rat, and we always had it on a Friday for some reason, or when we did the rat dissection, let's just say I had enjoyed university life the day before, and therefore it was not a good thing to be opening up the insides and being exposed to those smells. So yeah. Right, so we know that gas exchange happens at the capillaries in the gills. So we're talking about the gills. So we know that we're going to have oxygen going in and carbon dioxide coming out. So that's important to note that we're going to have oxygenated blood. So this, therefore, we're going to say is oxygenated. And that oxygenated blood is going to circulate around to capillaries in the rest of the body. We know that the rest of the body is going to need respiration to occur. So respiration means that they're going to be taking the oxygen out and they are going to be giving the carbon dioxide back into the blood. So therefore, what we can note is we're going to have deoxygenated blood. So name the type of circulatory system. Well, you can quite clearly see there's not 2 circuits. There's not a double circulatory system. Well done. So we can say it's a single, and it's a single closed system. However, Sarah, just to answer with yours, you would get an ignore marking point for the closed part. They're not bothered about that. They are wanting you to note that it is a single circulatory system. Now, if you were to add in too much, and if you were to say it was a single and an open system, you automatically lose the mark because you've given incorrect science. So you can say that it's single and it is closed, and all we're basically doing is we're just ignoring that, but you still get the marking point. Whereas if you were to say single and open, that's correct, that's wrong, you lose that marking point. So do be careful that you only answer the question that's being asked and don't give any incorrect science. Okay, so let's move on to the circulatory system of the sea bass and mammals are described as closed. Hence why it was ignored, because it was in the question that was coming up. What does that actually mean? So what does it mean when we talk about a closed system? Anyone want to guess? If it's closed, the blood stays in the capillaries. Exchange only occurs in capillaries. Yes, Amna, to answer your question, exchange only occurs in capillaries because if we were looking at our arteries and our veins, and there's a question coming up on this because I am aware of what this paper is going to show, that we therefore are going to say that yes, exchange can only occur where you have the one cell thick, the endothelial cells, which allow for exchange to occur. So blood is in vessels, blood held within vessels, blood enclosed in blood vessels. So basically, that is exactly what they want you to say, that the blood is enclosed, it stays inside. So the blood stays in the blood vessels. And those blood vessels are the artery, the vein, capillary. So make sure that you are giving them only what they ask. Okay, so moving on. State two differences between the closed circulatory system of the sea bass and the closed circulatory system of a mammal. So this is an interesting one because they have given you the picture above, and then they want you to use your own knowledge of the mammalian circulatory system. So they know that you have studied the mammalian circulatory system in more detail. So what they want you to do is to look at the difference between this one here and the one that you know. So you're saying double versus the single, L, well done. So the fact that we have got a double circulatory system in the mammals and the sea bass has got a single, that is a difference between the two. Zach, are you still in here with your question? I'm not sure if you are still in here. If you are, do you have to do practicals for biology? You don't have to if you don't want to get the practical endorsement. However, you are assessed on practical skills when it comes to the actual exam. So module 1 is the practical skills that will be assessed in the examination based around the PAGs that you should have done for the A level. So you should have done the PAGs. You don't have to actually pass your PAG, so you don't need to get the endorsement, but then the universities might not accept it. So you're saying no pulmonary and systemic circuit. So basically the no pulmonary and systemic circuit in the fish, what you're saying is you are basically repeating the double versus single. So that would be the same marking point, Amna. You wouldn't get a second marking point for that because you basically just reworded the same thing. So the fish has one atrium and one ventricle, whereas the mammal has two atria and two ventricle. Yes, that would get us a marking point. So if we were looking at the heart, we should know that there is a right side and a left side, and there are two atria, two ventricles. Whereas if we go up here, what we can see is that there is only one atria and one ventricle. So one atria, one ventricle versus, oh, let me change that around so it matches. Two atria, two ventricle, one atria, one ventricle would be another one. And then if we're thinking about how the blood actually circulates, you've got blood coming through the heart this way and blood coming through the heart that way. Whereas in this case, what we have is we have blood going through the heart once. So because we've got blood going through the heart only once, what that therefore means is that we are going to have only one pump, whereas in the other one, we've got two. Okay, moving on with the next question then. So this next one is looking at a group of students were examining a mammalian heart prior to dissection. The atrium ventricles were clearly visible. Name two arteries. So your arteries, what they're wanting you to note is there are three arteries. Good, aorta is correct. Which side does the aorta come from? Good. So the aorta is going to be from the left ventricle to the aorta, and the pulmonary artery, therefore, is the right. So what's my third artery? Nice, Andres. Absolutely. What are they called? It's like you knew I was going to ask the question. Nice. Very good. So the other one you could have given was the coronary artery. So it's important that you do note that there are three, because in the past, what they have done is they've given you a picture of the heart, which has been dissected, and they've given you a picture of the outside of the heart and asked you to name the vessels that you can actually see. So the ones that supply the heart with the blood, the oxygenated blood, are your coronary arteries. And why is it that they are different to the aorta and the pulmonary artery? Why is it that the heart needs the supply of oxygen so quickly? Anyone want to guess on that one? Why is it? Because the heart's respiring. What do you mean by that? You say the heart's respiring. I'm not liking that answer. So think about how to reword that. Why is it that the coronary artery is needing to have its own accessible blood getting to the heart? Oh, bless you. I actually think if you're saying last year's paper 3 you thought was hard, I'd say don't do paper 1 and 2 because they were harder. Um, so the heart can contract and relax. Okay, so we're getting closer. So Anna said it was because the heart's respiring, but I didn't like that answer. And you said so the heart can contract and relax. So, so what is it that, okay, so the heart cells, because remember the heart's an organ. So be careful, Amna, with what you said. You said the heart, talking about the organ, whereas if we're talking about respiration, we're talking about cellular respiration. If we're talking about the muscles contracting and relaxing, so that's going to our module 5, animal response knowledge. We need to understand that these are cells, cells that need to have the ability to contract. So for them to be able to contract and relax, they need a constant supply of oxygen so that cellular respiration, aerobic respiration can occur, because aerobic respiration gives us a higher yield of ATP molecules. So it's really important that you're trying to link those different topic areas together and you are specific in your wording that you do. Oh, I have to say, plants is horrible until you get it. Once you get it, plants is much better. Okay, let's move on. Right, so the students then carried out dissection of the heart. Figure 2.2 is an example of the drawing from one of the students. Well, these students did not do well. That is correct. It is the septum. So the septum is the bit that's going to separate the left side from the right side. And if you are born with a hole in the heart, that basically means that there's a gap in between, which will result in blood being able to move between the left and the right ventricle, and therefore decreasing the pressure. Okay, here we go. So this question, again, this is a assessment of module 1 alongside module 3. And what they're doing is they're assessing your ability to, one, do biological drawings or evaluate someone else's biological drawings, and also to be able to improve. So the evaluation side of things should be about you knowing how to improve. So let's just go back up. So they want us to give 3, which we are saying are errors, and then corrections that you would make. So here is their diagram. They want you to say 3 things that you would say that would correct the diagram. Yes, this session is recorded for, sorry, I've just noticed some messages on the YouTube, because I'm not really looking at that, but yes, it is recorded. Is the left ventricle on the other side? Hold on. So label lines should be parallel. Wrote left ventricle when it should be the right ventricle. So it's an interesting one when you're looking at this of trying to figure out which way round they've got it. So you're saying, first one, label lines should be parallel. So the label lines ideally should be parallel, but interestingly, they're not giving that as a marking point here. The right ventricle is not labeled correctly. It's the left ventricle on the other side. Left ventricle when it should be right. So one of the things for you to note is when you're looking at this, which way round is which. So you're absolutely right. If we think about this, we should have the right ventricle down here, and this one should be the left ventricle. So that's one of the things that they've done wrong, that they have labeled it the wrong way round. What else have they done that's wrong? What else is a way in which they can improve it? So, Andres, you said the right ventricle is not labeled correctly. You wouldn't see that in your label. So, Andreas, they wouldn't actually have the Purkinje fibers shown in the dissection diagram. So we've done that the left ventricle should be on the other side. The right ventricle is not labeled correctly, but nobody's told me what it should be labeled. That's not a tricuspid valve. It should be aorta. No, be careful. If you had have said the aortic valve, I would allow that, but not the aorta. The aorta is a blood vessel. What you want to say is this is a semilunar valve. So just be careful again on that one with your wording, aortic valve or pulmonary artery valve, they'll allow, but you want to say it is the semilunar valves. So the tricuspid valve should actually be, if we were doing my box again, between the right atrium and the right ventricle, you would find the tricuspid valve. In your exam, do not stress about the tricuspid and bicuspid. They don't want you to actually give that name. They've made it much simpler for you. You call it the atrioventricular, again, if I could spell, atrioventricular valve. So the atrioventricular valve is the one that goes between the atrium and the ventricle. So it doesn't matter if it's the left or the right side, it's always the atrioventricular valve. Is there anything else? Should say, nice, there we go. We've now identified that should say the left ventricle, nope, left atrium and not the right ventricle. And there's one other thing that's wrong with this diagram. And it's because they've got it the wrong way around. But the other thing you should note is they've drawn the wall thicker on the right side compared to the left side. Paul, to answer your question, no, they won't lose a mark if they call it the tricuspid valve. I teach it, the tricuspid valve and the bicuspid valve, and they will actually still get the marking point if they say the mitral valve for the bicuspid valve. However, what they've done is they've tried to make it easier for the students. They've removed them and just call it now the atrioventricular valve. So a lot of students still struggle with whether it's the bicuspid, tricuspid. So I always try to tell them, do it with the atrioventricular valve. Yeah, the size between the two. So because they got it the wrong way around, that's what they were looking for. So that's what you'd be filling in this section below. This one's there when it should be there. This one's here when it should be here. And here we go. I love this question, but most students hate it. So this is a 6 marker. Could you say no title? No, I wouldn't say, because they haven't asked you. Yeah, they specifically said it was about the structural and labeling errors rather than about the biological diagram. So if they said about the biological diagram, then I would add that in. This is 2021 paper 2. But I do love this paper. I love this paper because it's such a nice. What are you talking about? Saying I'm not a girl? Hello. This grey hair doesn't mean anything. I dyed it this way. This was what happens when you have children. You have 2 lots of children. I used to have amazing hair, which was jet black, straight as it come. And yeah, then children came along and I had no more time to dye my hair back again. So then the greys, look at that, which is amazing, actually. I loved in this because I actually talk about the fact that this is the lack of pigment, therefore the lack of the expression going on. But anyway, we'll get to that when we do Year 13 stuff. Um, yeah, year 13 is rough. It's rough, but actually, I would say some of the questions in year 12 papers are actually harder than the questions in year 13, which is why I always advise you to also practice, if you're year 13, those AS papers, because you're identifying gaps in your knowledge for the year 12 content. And if you don't have a strong foundation of that year 12 content, the year 13 becomes so much more harder. Whereas if you have that strong foundation of year 12, then year 13 is a little bit more accessible. But we still make mistakes and we're still learning. Right, moving on then. So 3 types of blood vessels. Here we've got our artery, our vein, and our capillary, and we've been shown a red blood cell. Now, what they want you to do is they want you to really take the time. I found, Paul, do you know what? To be honest, I found the last year of my degree to be so much better than the first 3 years. And I think it's because I was lucky because I went to university in Scotland. I did a 4-year course. So because I did a 4-year course, my first 3 years didn't count. I had to pass the exams to get into the final year, but everything counted on that final year. And for some reason, it was just a switch that went on in my head. And I actually really figured things out and I worked at it and I did really well. I got a 2-1. I didn't get a first. I always joke and say anyone who got a first didn't have fun at university as well. But I was also working other jobs as well as university. But it didn't make sense until the final year. And because I could specialize a bit more, I then actually did much better in that final year. And yeah, that's how I got into. Oh, see, yeah, absolutely not. I mean, my kids are only 6 and 4. One's about to be 5, and I'm literally, yeah, not able to function some days because of my kids. They keep me up most nights, especially when they're like, "Mommy, can you come to my bed? I've had a nightmare." Fun times. You guys who are in your young years have still got your lives ahead of you. Please go travel the world, go see everything out there before you set yourself down to be ready for the amazing thing that happens with having kids. Don't get me wrong, I love my kids to bits. They are amazing. They make me laugh. But it's tiring, especially at my age. Okay. Oh, where have you gone? Oh, no, it's fine. Didn't want me. Okay, so here we go. We're going to look at it now. I would say, again, identify elastin layers. They've told you information here. Smooth muscles, smooth muscle. They've told me information, so use it. Collagen, collagen. They've told me information, so I am going to, which one have I not used green? Use that to guide me on what it is that I need in the exam to discuss, because it's a 6 marker and it says, and this is, I don't understand this sometimes when I'm marking these, when I'm looking at what students write, I'm like, did you completely miss this part here with reference to figure 2.3? So many students read this question as if that is missing and just write, describe how the structure of each type of blood vessel is adapted to its function. So if they haven't actually looked at this and used the information that they've given you, you're automatically limiting yourself. Exactly. It always comes back to read the question. So you have to read the question to ensure if you don't give reference to any data in figure 2.3, you will limit yourself to not 4 out of 6 or 3 out of 6. You are limiting yourself to 1 to 2 marks out of 6. So you must make sure that when you are doing questions like this, and it comes up so many times, and every examiner's report that I read always says the same things. the students didn't use the tables or graphs or diagrams that were given to them. They give them to you for a reason. They want you to be able to pull the information out of it. Because if you are going to, let's say, peer review someone else's scientific investigation, what's going to happen is what you need to understand how to interpret their data. You need to understand how to interpret their diagrams, their investigation, their method, their sampling techniques. You need to make sure that there is the right number of variables, that they have the right number of repeats, have they done statistical tests, etc. Use the stuff they've given you. I don't think it's just that they see what they want to see. I think it's also that they become overwhelmed. They see a picture like this with lots of information and they just go, oh, I didn't get taught that. And so their brain naturally switches off and they think, well, I'm just going to blur on paper everything I know. And because they do it that way, it means that they miss bits out. I always call it that for me, especially when there's a maths question that comes up, I hate it. I really struggle with maths and takes me a long time, and I think it's just because of the way my brain works, but I literally switch things around. I do things in a very backwards way. So when I was doing my maths what would be equivalent to AS level, when I was doing the math side of that, I really struggled. And if I didn't have the tutor that I had to help me to not only be able to learn the stuff, but also help me with my coursework, I don't think I would have passed my maths exam. And so I really struggle and I get what's called this wall of awful. I literally stare at the question and I get a blank screen. And I have to sit for a long time to really understand what's in front of me. And it's such a hard thing. And it's an interesting one because a lot of biology teachers actually do struggle with their maths. And yet maths is a vital part of the course and we have to teach it. So we teach it in, I would say, the most basic way we can, which is why you, as a student, go out there and find there's very little information to help you. And sometimes it's actually better to go and ask a maths teacher, but then not again, because sometimes they go too complex into it. So it's really hard to find the right middle ground for you to get the necessary skills to pass the exam, but also to help you to understand it. So I would definitely say that maths is my like weak point. And whenever I look at a question, it's not that I see what I want to see. It's like literally this wall of awful, this blank screen goes up and I'm just like staring at, I don't know, nothing, it feels like, because no matter how much I try, it takes a long time to access that. Yeah, and that's the thing. For some places, if you have a chance in school, especially for year 12, for finding someone who is a maths tutor or a student who's studying maths to help you, then that really works. The other thing is also age is a big factor in it. And that's the same with reading and math skills. The way that students are taught maths now to the way that we were taught when we were at school is so different. And it's the same with like phonics to how we were taught. And so as a parent, and I mean, I've been teaching, I've got a degree, I've got a master's from Cambridge University, I've got my postgrad, I've got my undergrads, I've got these degrees, and yet my 4 and 5-year-old daughter, when they came home with these phonics books and were asking me to try and help them to sound things out, I didn't have a clue. And I'm still struggling and figuring it out. I could never teach the little kids. But yeah, it's that whole thing of you've got to find someone who helps you understand it. Anyway, I've got a bit of a anyway, I diverted. So let's come back to this question. Yeah, log tables are horrendous. So what's it actually asking us to do? Use the figure to describe how the structures is adapted to its function. So looking at what is elastic layer, we talked about this last time, and we talked about the fact that this is made up of fibrous proteins. And those fibrous proteins are for the stretch and recoil. So if we understand that the elastic layer is about that stretch and recoil, then if we look at the numbers 330, 39, and then nothing obviously in the capillary, we use that to explain that structure. Why is it that the artery has got a thick elastic layer? Why does it have a thick elastic layer? Well, you need that elastic layer, like my bubble here. I need, if my blood is coming through here, my blood is being pumped in from the heart. Oh, that's just been flying. The heart is obviously going to be pumping the blood into the artery. That's going to open the lumen. So the diameter lumen is going to open slightly for that blood to flow in. So that stretch is required. But what you need is that stretch and recoil, because that will continue the blood flowing down in the right direction that we want it to go. So you have this elastic layer, which is going to even out the surges from that pump that comes from the heart, but also allows for this continuous flow of the blood, because we, remember, need the blood to go from the heart all the way around the body and back to the heart. So we need this continuous flow, and therefore having that elastic layer means it can do that. The other thing to think about is, so the collagen, what's collagen for? Well, collagen, again, another fibrous protein that we need to know about. So collagen is a fibrous protein. What's it for? It's got a structural property. It supports, so therefore make sure that the blood vessel maintains its shape, because we need the blood to be flowing. And if we're going to stretch the lumen size, we're going to stretch with the elastin being able to get wider. Well, if it goes too far and there's nothing stopping, so pushing back, that would then potentially mean a rupture. So the collagen maintains that shape and the volume. So again, it's about, what do you know about those fibrous proteins, and then how can you use that to guide you to answer this question? Then what does a muscle do? Well, you should know that a muscle is about the contraction. So it contracts and relaxes. So if you have a smooth muscle that can contract and relax, it is therefore going to change the size, again, of the lumen. If it contracts, it is going to constrict the blood vessel. It's going to narrow the flow of the blood. If it dilates, it's going to widen the lumen, therefore allowing more blood to flow. So that smooth muscle being able to contract and relax, allowing for that change of the size of the lumen, means you're able to control your blood pressure. And obviously, it needs to be able to withstand, again, the pressure of the blood that's being pumped out of the heart. So that smooth muscle also provides strength to withstand that pressure. So if we look at the veins then, well, the veins are at the end. They're further away from the surging of the heart. If they're further away, they're not going to feel that surge as much, and therefore there is no need for them to have this small lumen. They've therefore got a larger lumen, and they are going to be under less pressure than the arteries. But what do they need? Well, they need to be able to move blood against gravity. Because if you think about it, when my heart is pumping all over my body, up to my head, out to my fingertips, but also down to my toes. So it has to be able to move against the force of gravity. And so therefore it needs the ability to flow away from the being pulled down. So you also need to have the fact that the heart is going to push the blood the heart, the veins, sorry, are going to push the blood back to the heart. And therefore, it needs to have muscles that can contract to help with that movement. It needs to have elastic layer, but not quite as much, because obviously we're now at the veins. It needs to have more collagen than the arteries because of the structural support, because they carry more volume. With a larger lumen, you're going to have more volume being able to flow through that blood vessel. So because of that, because that increase in volume, you need a thicker layer. So you should note that the collagen is slightly thicker when you look at the vein compared to the artery. And then yes, that was the last thing I was about to say. Because of the backflow that would happen, that wider lumen, therefore that lower pressure. I always like to think of it like a school corridor. It's a bit weird, but imagine a school corridor where it's really wide and you've got students milling around all over the place. Some students go to the class because they forgot their books and whatever, and the others go off to the next class. Well, if we didn't have valves preventing you going back into the classroom, doors that stop you from going, that would therefore mean that you would be flowing in the wrong direction. The pressure changes, that would therefore result in mixing. So because of that, we have these valves that prevent the backflow of blood. And then the other thing to note as well, because remember, we want to use all of the information, is to look at the capillaries. Now, it's interesting, the capillaries are 9.5 micrometers. The erythrocyte is 8 micrometers. So quite clearly, they've given us some information in this question by telling us that the diameter of the erythrocyte is so close to the diameter of the lumen. Therefore, what we were talking about before, we've got a short diffusion distance. Now, in a 6 marker, they're not expecting you to do all of those. What they're expecting you to do is to give them at least something from the diagram on each of the blood vessels. And it's important to note that they have actually said the structure and the function. So I would say if I'm marking this, I'm going to be looking for an S and an F, and then I'm going to be saying, right, well, there's structure 1 comment, there's function 1 comment, there's structure 2, there's function 2, structure 3, function 3, and so forth. And then I'm going to be looking for data. So they will be looking for you to have mentioned something about arteries, capillaries, veins, and then given data, which refers back to that table for you to get that potential 6 marks. Right, I'm going to stop there for tonight. Not necessarily, Paul. In the case of the 6 markers with the OCR-A, it's not always 1 point per mark, especially for them for 6 markers, because what they get is a level system. So they have a level 1, level 2, level 3. So it depends on the question. So it could be that the question is asked 3 different parts of the question. So in that case, they have to give part 1 plus part 2 plus part 3 plus extras to get between 5 and 6 marks. If they only gave a part 1 and a part 3, let's say, answer, they would limit themselves straight away to potentially only a 3 to 4, even if they've written loads. So it's really important when you're doing those 6 markers that you're reading the question. So as I've said here, there's an S, there's an F, and then there's data to maximize that grade. So you are very welcome. Guys, if you are year 13 and you're still looking for some help, obviously, I am doing my session in Easter. There are a few more spaces left. You're welcome, Iris. And I will be back on Monday. So yeah, thank you for joining me.